Alright, so I'm just going to explain through number 4 because it's easier than trying to show it in a picture. So for our inelastic case, it's very easy. We have our bullet with its mass and velocity. Because we have our resting block, it has no momentum, so we essentially don't even care about it. So that means that after the collision, we have the bullet in the block. So now we need both masses times that velocity, and they're calling this velocity A. So we're going to solve this for velocity A. So velocity of A is equal to m1 v1 initial over m1 plus m2. So this will be what we come back to for that velocity. And this is my A. So now I simply need to combine them using the elastic case, much bigger pain in the butt. So here we have our bullet, just like before. We still have that stationary block, so you don't really care about it. Afterward, though, now we have our bullet moving in the opposite direction, and we have our block moving in the forward direction. And here they give that velocity the name of A prime. So first thing we need to remember is that A prime is really V2 final. So whichever way you want to work it through. Next most important step, there's a lot of algebra that goes into it, and on the online Quest homework stuff it will show the algebra of how to get there, but ultimately all we care about is from the formula chart. We have a known value or a no constant, and it's a proof, so we just trust the proof, or they can work it out in like a 7-step process. So the proof is that the initial velocity of the first object minus the initial velocity of the second object should equal the final of the second minus the initial. So essentially we're trading positions, and that's what takes care of or algebraically corrects when we have the direction changes and such. So using this as our idea, and again remembering that we lost our momentum of our block from the beginning because it was resting, so I can cancel that out here. So now I'm going to build off of this idea that the initial velocity of my first object has to equal the velocity of my second object, which, remember that 2 final is actually A prime. So this is now my formula. So once I'm here, I want to essentially solve for this so that I can replace it here. So when I do that, I'm going to subtract this to move it over. And then I can swap my signs so that I end up with my positive value of V1F there. So now I'm going to take this value and use it to replace this value here. Shrink that down, give myself some space. Okay, so now my equation is m1 of the bullet has to equal m1 times my new formula. Plus m2 A prime. So this is the new version of this. Now I start solving for A prime. So algebraically distribute combine like terms, so getting my A primes together and getting my V1s together. So, oops, I messed up here. So this was actually negative V1, which means this is a negative. So subtracting by a negative is going to actually make it a positive. So now I have 2 times M1 V1 initial. It's going to equal the remaining variables here. Again, trying to isolate common terms. Oops. So isolating my common terms here and here, which means doing a little more algebra. So 2 M1 V1 naught equals M1 plus M2 times VA prime. Move this over by dividing. And so now I'm ultimately left with A prime is equal to 2 M1 V1 naught over M1 plus M2. So this is my A prime. So they want it in terms of, what was that equation? M1 VA over VA prime. So lots of algebra. M1 V1 naught over M1 plus M2. I like to think of it as VA times the inverse of VA prime, so from what we do, so M1 plus M2 over M1 V1 initial. Cancel out what I can. So those cancel. And this M cancels this M, this V cancels this V. I'm left with the 2 on the bottom, which means that this becomes my factor. Fun, right?